Hey y'all, welcome to Miss Clarke's chemistry class. I'm here to help you make sense of everything you've been learning in class. In this lesson, I'm going to teach you about balancing chemical equations. Actually, I'm going to release 3 videos on balancing chemical equations. An introduction, how to, some tips and tricks for those difficult equations, also how to take the word equations and translate that into a chemical equation. This one specifically, intro. So if that's what you're looking for, grab your notes and let's get started. So before we start balancing some equations, let's first understand why we balance equations. We balance chemical equations to obey the law of conservation of mass, which states matter is not created or destroyed. Let's think about what that means. We could restate that as the reactants have to equal the products. Whether we're talking about particles, the number of particles in the reactant has to equal the number of particles in the product, and vice versa. Or we could talk about mass. If we had a total mass of the products and the total mass of the reactants, they have to be equal. If we have more particles in the reactants than we do products and we've lost some particles somewhere, that means we've destroyed matter. We can't do that. Or if we look at our particles and our products and we have more, then we've created matter, and we can't do that. So to show how a chemical reaction is actually occurring and in what quantities, we've got to always balance our equation. Let's jump in and do some practice. There's more than one way to do this. In my experience, using the chart method is the best place to start, especially if you're a beginner. But if you see that you don't really need it, that's okay. Okay, to use the chart method, I'm going to draw a line between my reactants and my products. Let's remember, everything over here to the left, that's a reactant. That's our starting materials. Everything that's over here to the right, that's our products. That's our ending materials. We always say reactants yield products. We need to list all of our elements on both sides. Now, I normally start with my reactants. I've got 1 zinc, I've got 1 hydrogen, and I've got 1 chlorine. I like to keep the same order on the products, even if they're in a different order. If we have zinc here, we're going to want to compare that to zinc over here. Hydrogen here, we want to compare that to hydrogen. So we want the same elements to be beside each other so we can better see what we have. So let's get back over to our products. We have 1 zinc, we have 2 hydrogen, and we have 3 chlorine. Now, we can only add coefficients. That means we can only put numbers in these blanks. What we cannot do is add subscripts. We can't change these subscripts. We can't add new subscripts in. I couldn't just throw a 3 right here so our chlorines are equal on both sides. We can't do that. What we can do is add coefficients. Now look, our zinc, it's already 1 and 1 on both sides, so that is not where we would start. So let's look at hydrogen. We've got 1 hydrogen in our reactant, but we've got 2 hydrogen in our product. So we want there to be 2 hydrogens in our reactant. So I'm going to put the coefficient of 2 there. That's going to give me 2 hydrogen. It did affect my chlorine. Now I have 2 chlorines. Hydrogen looks good. Let's look at chlorine. We've got a 2 and a 3. Now, is there a number we can multiply by 2 to get 3? If there is, then that's the number we need to use. There isn't. And so I'm hoping that you're already thinking about the number 6. We need for there to be 6 chlorines on both sides because that is how we're going to make these even. So I'm going to put a 2 here. That's going to give me 6 chlorine. Oh no, it messed up my zinc though. Let me change that. Now let's hop back over to the reactant side. Now I did put a 2 there. You're going to have to be willing to erase. If we want this to be a 6, we're going to have to put a 6. 6 chlorine and 6 hydrogen. So let's fix our hydrogen. We messed up hydrogen. Let's go fix it. So if we put a 3 here, Now we've got 6. Our zinc still isn't fixed. We've got 2 zincs on our products. We need to have 2 zincs in our reactant. Now, your coefficients always have to be in the lowest whole number ratio. So if we look 2, 6, 2, 3, there is not one single number besides 1 that's divisible by all of those numbers. That's how we know we did a good job. Let's do another example. Again, I'm going to keep doing the chart method because it has proven over and over and over that it's the best method for beginners to start with. Okay, so I'm going to list out my elements. I've got 10 carbons, 16 hydrogen, and 2 chlorine. Again, I want to leave those elements in the same order so we can compare them side by side. In our products, we've got 1 carbon, we have 1 hydrogen, and 1 chlorine. It really doesn't matter where we start here because nothing is balanced. So let's just go ahead and start with our carbon. We've got 10 carbons here. We've only got 1 carbon here. So we can just put a 10 here. It only affected our carbon. So let's just keep going. Hydrogen. We've got 16 hydrogens in the reactants. So I could put a 16 here, and that's going to give me 16 hydrogen. It also gives me 16 chlorines. So my hydrogens are balanced, but I just messed my chlorines up. I like to fix it, mess something up, fix it, and then go mess something up, and then fix it, and then you're going to go back and forth until finally everything is fixed. So 16 chlorines here. We only have 2 chlorines here. And so if we think, what is a number we can multiply by 2 to get 16? We can put 8 here to get our 16. If we go back and look at our coefficients, we've got a 1 here because that's an understood 1 when it's a blank. So 1, 8, 10, 16. Yes, these numbers are all even, so they're all divisible by 2, but we've got that 1 right there. Anytime you have a blank or a 1, you know you're in the lowest whole number ratio. Let's try another one. Okay, so I'm going to draw my line to separate my reactants and products. I'm going to list my elements. I have 1 iron, 2 oxygen, 2 iron, 3 oxygen. There is always a reason why I start where I start, and I will always bring this up to you. But a lot of the times, you're just not going to figure those types of shortcuts out until you've got a lot of experience. Here, I'm going to choose to start with oxygens first. And that's because there is not a common number. There's nothing we can multiply by 2 to get 3. So again, we need to be thinking about 6. So we need to be able to turn this into a 6 and this into a 6. So that means we need to put a 3 here and a 2 here. That gave me my 6 oxygens on both sides. Oh, but look, now iron, I've got 4. But that's okay. That's a super easy fix. I'm just going to go push 4 on the other side. 4, 3, 2, lowest whole number ratio. Let's do another one. I'm going to separate my reactants and products. I've got 3 carbon, 8 hydrogen, 2 oxygen. Again, I'm going to keep that same order. Carbon, I've got 1. Hydrogen, I have 2. Oxygen, oh, look at oxygen. We've got 2 oxygens and 1 oxygen, and they are connected by this plus sign. So we are going to do 2 plus 1 equals 3. We have 3 oxygen. I am going to create a tips and trick video for all of those valuable tidbits that I have gained through experience all these years. I'm going to share those with you. But one of them comes to play right here, so I'm going to go ahead and give you a sneak peek. Anytime you have an element that stays together in one place on one side, but is split on the other, see how oxygen is just in one place in our reactants, but we've got it in 2 places in our products? Leave that element till last. And oftentimes it is oxygen. So we are going to leave oxygen till last. So let's start with carbon. We've got 3 carbons in our reactant, so let's put 3 carbons in our product. Let's adjust our number. Now we've got 3 carbons. We've got 6 oxygens plus 1, that's 7. Again, we're saving it to last. So even though I messed it up, let's go to hydrogens. So we've got 8 hydrogens in our reactant, so we could just put a 4 here, and we've got 8 hydrogen Yep, I messed up oxygen again. Let's recount. So we've got 3 times 2 is 6, plus 4 times 1 is 4. 6 plus 4, 10. And if we go to the other side, we've already got 2. So what times 2 equals 10? So we can just put that 5 there to get our 10. 3, 8, 10, 3, 8, 10. We're good. When we look back at our coefficients, we've got 1, 5, 3, 4. We're good there too. Let's keep practicing. So again, separate it out. Write my elements. I've got 1 phosphorus. I have 5 chlorine, 2 hydrogen, and 1 oxygen. Again, I'm going to keep the same order. Phosphorus, I've got 1. Chlorine, I've got 1. Hydrogen, 3 plus 1, we have 4. Does everybody see that? 3 plus 1 is 4. And then lastly, oxygen, and we have 4. So if I'm starting at the top, my phosphorus already are okay. So maybe I would just start with chlorine. So I've got 5 chlorines on my reactant. So I'm going to put a 5 here to get 5 chlorines on my product. That also gives me more hydrogen. So hydrogen, I have 5 plus 3. So I'm going to have 8 hydrogen. Hey, we messed it up. Nope. Not going to fix it. We've got hydrogen in 2 different places here. That tells me to do it last. So I'm going to skip hydrogen. I'm going to go ahead and look at oxygen. I've got 4 oxygen on products, 1 oxygen on the reactant. So I'm going to put a 4 here. Oh, and look, I fixed oxygen, but I messed up hydrogen. 4 times 2, that's 8. I'm going to go fix it. 8. Didn't even have to do anything. So even though that was a lot of letters, I only had to put 2 coefficients. Don't let those really long ones really mess you up, because sometimes the more letters they have, the easier they are. I've got one more example for us to look at. I know this one looks a little bit challenging, huh? Again, it's got lots of letters. That doesn't necessarily mean it's going to be hard. Okay, we've got 3 calcium. We've got 2 phosphorus. Don't forget to distribute the 2. The 2 is going to go to the phosphorus and to the oxygen. So oxygen, we have 8. Oh, wait a minute. I've got more oxygen over here. Let me back up a little bit. We don't have 8 oxygen. We have 8 plus 2 oxygen. Do we see that? 8 plus 2. So we actually have 10 oxygen. And then we've got silicone, which we only have 1. Okay, on the other side, let's keep it in the order. Calcium, 1. Phosphorus, 4. Oxygen, we have 10 plus 3, 13. Oh, I don't like that. Silicone, we have 1. Let's go ahead and just start with our calciums, just right there on top. So I put a 3 here, 3 calciums. Let's fix everything that I messed up. So now there's 3 silicone. We've got 3 times 3, 9 oxygen plus 10, 19 oxygen. Oxygen is split on both sides. I'm definitely leaving oxygen till last. Hopefully they'll just fix themselves and I don't have to worry about it. So let's go to phosphorus. 2 phosphorus on the reactant side. So I'm going to go ahead and put a 2 here. Now I've got 4 phosphorus, but I kind of messed some things up. Now I've got 6 calcium. I have 8 times 2, 16, 17, 18 oxygen. Oops, 18 oxygen. Okay, now this is getting a little crazy, right? I agree. But since we just fixed our calcium, 6, let's go ahead and change that right here. So instead of having 3, let's put a 6. That's going to give us 6 calcium. That's going to give us 6 silicone. That's going to give us 6 times 3 is 18 plus 10. That's going to give us 28 oxygen. If I go over, because I'm still planning on leaving oxygen till last, so let's look at silicone. We have not messed with silicone yet. If we look at our products, we've got 6 silicone, so let's put a 6 here. 6. Okay, here we are finally to the oxygen. Let's count these up. We have 6 times 2. That's 12. I'm gonna do a little mental note over here. 12. And then let's look over here. We've got 8 times 2. That's 16. So if I'm going to add my 16 and 12, 28. Lo and behold, it did work itself out for us. So we have 2, 6, 1, 6. Lowest whole number ratio, we are good. This one was a tiniest bit of challenge, but it shows you just don't give up. Go back and forth. Fix something, mess something up. Go fix it. Oops, I messed something else up. Back and forth until you're all done. Okay, so that's balancing chemical equations. Make sure and stay tuned for that next video. Tips and tricks for those difficult, hard to balance equations. I'm going to share all of my tricks with you. So stay tuned for that. Until next time, bye y'all.